Okay, so here we are with the beginning of our chemistry unit, and this lesson is all about the symbols that we use for common elements. And I'm joined today by Miss Brophy, who's going to be helping me out. How are you?
Okay, so far.
Good. So this is very, very common for most people or for most students because you probably looked at some elements when you're in grade 7 or 8. So let's recap first of all. An element is a particle made of only one type of atom. Okay, so an element, this is what we're talking, the elements that we're going to be discussing, they're particles, but they're only one type of atom that's in there. So different chemicals, and perhaps the most famous one, like you know, H2O, which is of course water, that is not an element because it's made of different types of atoms. So this, we're talking about something like gold. Well, what's gold made of? Well, it's made of gold atoms, and so that would be an element. Okay, so the important thing is that we have some rules that apply to how we write symbols, because every single element has a symbol that's associated with it. And Miss Brophy is going to take us through some of these rules. Okay, so rule number 1.
Okay, so the first letter is always a capital. So when you're making the symbol of the element, you're going to want to make sure that you use a capital for if it's the first letter. Often the symbol for a particular element is the first letter of that element's name, but that's not always the case. A good example of one that is carbon. The symbol for carbon is C.
Okay, so here we go. So we have the first letter. Okay, and so we're just going to recap this, as Miss Brophy said. So the first letter in any symbol is always a capital letter, and very often the symbol for an element is the first letter in the name. Okay, so we'll write this down here. And we have a great example is in the name. Okay, so a great example is carbon. Okay, and so the first letter in carbon is C, and indeed that is the symbol for carbon, is capital C. Okay, so rule number 2.
If there are 2 letters in the symbol, the second letter is not capitalized.
Okay, perfect.
I'm going to let you
Yep.
write that out.
Yeah, the second letter is not capitalized.
That's very important because you could get confused easily otherwise.
Yeah. And those reasons will become important later on as well. So
usually if there's a 2-letter symbol, it's made up of the first letter and the second letter of the element.
perfect.
Yeah.
So an example of that?
Is calcium. So calcium, Ca, the first 2 letters. You use a capital C and a small letter A. You do not write capital C, capital A.
So I'd write it like that?
Yes.
Okay. And not like this?
Nope. Wrong. That means something completely different.
Yeah. Okay. Rule number 3.
Some symbols are derived from Latin words. There's a fair bit of Latin in science. I don't speak Latin, but...
Mm-hmm. So, okay, so derived from Latin words, like what?
A good example would be copper. The symbol is capital C, small u, and that's based on the Latin word cuprum. And the first 2 letters of cuprum are CU.
Gold would be another example of that.
Mhm.
Gold's chemical symbol is AU, and of course, that it's
Aureus?
yeah, it's aurum.
Aurum.
Okay.
Okay.
So, element names. Last, instead of writing the symbols, what if we wanted to write the element names though? How do capitals work then?
There are none. Element names are written in lowercase letters.
Okay.
Do not use capitals, not like how you would for people's names. So.
So we could say element names are written in lowercase letters.
Yeah. An
So-
example would be sulfur in small letters, not sulfur and not
Yeah.
sulfur. I don't know how to describe capitals with my sulfur.
Yeah.
Yeah.
Okay, here we go. So we'll do this, SULFUR.
Yeah.
And so what we want to say is we don't want not
Sulfur.
this, not all caps,
Yeah.
okay? So we don't want all capitals. We don't want the first letter capitalized because that's really important, right?
Mm-hmm.
So we don't, these are mistakes. We don't want those. Okay, so when we go through, we want to look for the elements. Obviously, on the periodic table, there's hundreds and hundreds of elements. We're not going to expect you to memorize them. However, we are going to expect you to memorize some important ones, some very common ones. And so this is the list right here that you've got in your note. This is what we want you to memorize. You have a list of 30. And this is what they are: aluminum, argon, barium, bromine, calcium, carbon, chlorine, copper, fluorine, gold, helium, hydrogen, iodine, iron, lead, lithium, magnesium, mercury, neon, nickel, nitrogen, oxygen, phosphorus, potassium, silicon, silver, sodium, sulfur, tin, and zinc. What you'll notice on these ones is that the Latin names are all given, but they're given in brackets right beside. So mercury is hydrogryum, or hydrogryum. And so you'll also notice that sodium is natrium, argentum is silver. And so these are all stannum. These are all the different names, the Latin names. There's also some comments here. The important thing is not the comments, but this right here is kind of one of those crucial little things, is that spelling is important, right? We don't need to memorize the Latin spellings or the Latin names, but spelling does count. So when we're trying to spell words that are a little bit tricky, like aluminum or magnesium, you know, that's going to take some practice for some of us. So what's this down here?
This is the periodic table of the elements, and it's going to be your best friend in this unit, and if you keep going in chemistry later in school. Basically, it's just a way of showing the different elements in an organized way, and you'll learn more later about how it's organized. And the ones on here that are sort of highlighted, those are just the 30 ones that we've covered above, where you have to memorize the name and their symbol, and this table shows their symbol.
Okay, so most of the time, like we use an example with gold, most of the time, for most symbols, the symbol of the element is the formula of the element as it appears in nature. So like, for example, a piece of iron is made up of iron atoms and is represented by the symbol Fe. A hunk of gold is made up of gold atoms, right? And so that's it. That's all that there is to it. However, and this is why we're talking about this, some elements exist as molecules, not atoms, okay? And these are called to be the diatomic elements. And there's a couple very, well, there's a set that we're going to talk about right now. Remember, di means two. So when we talk about diatomics, we're talking about two atoms, okay? So these are the only molecules in nature that exist as molecules, but they're still called elements, okay? And they are hydrogen, which in nature is H2, nitrogen, of course the most abundant gas in our atmosphere, oxygen, fluorine, chlorine, bromine, and iodine. Okay, and so these 7, you'll notice that there's a little subscript. This means 2 of them, obviously, and so these you are going to want to commit to memory as well. Okay, you'll notice, however, that it's not a coincidence that some of these, fluorine, chlorine, bromine, iodine, hydrogen, nitrogen, oxygen, they're all kind of in a very specific little spot, and they kind of all exist right where we'd expect them to exist. So that is your introduction to molecules.